So following some of your feedback, I thought I'd work through some infrared spectrums with you so you know what details to be picking out and which ones you can ignore, okay? So our first example is ethanol and alcohol, and I've put the display formula up in the corner for you. I find it really useful sometimes to sketch out the structure I'm looking at the spectrum for, because it means I can know which groups I'm going to be looking out for, which functional groups. I've also identified the fingerprint region in all these slides. That's the area which is unique to every compound which might go through one of these machines, and it tends to be the vibrations of larger sections, if not the whole molecule, which is what makes it unique, but also makes it a very confusing part of the spectrum to interpret with the reference numbers we use in A-level exam. So we tend not to look at that end of the spectrum. So I want to focus on a few things. So it's an alcohol, so we're going to be looking at the OH group. Okay, so I've highlighted them both in green, so where it is on the molecule and where it is on the spectrum. Now the OH has two bands, you might notice in your reference sheets, and those location of where the OH is absorbed depends on whether it's an alcohol or an acid. So in an alcohol like ethanol, you'll see it absorbed around 3,230, 3,350, and this is much higher than in acids. And the OH is what we call very broad, so that trough or peak, technically it's a trough, but I think we call it a peak in infrared spectrometer, is very broad, it's very stretched out. Okay. The other peak we can see, or trough, if you prefer, is around the 3,000 or just a little bit below. And basically any peak just under 3,000 is probably due to CH bonds, and we're probably going to find those in quite a few things because they're really common in organic chemistry. So we're now going to look at ethanoic acid, and I've put the display formula up in the corner again so that we can see what functional groups are we going to be looking for in the spectrum. And that COO and that OH bond are going to be probably the two main ones we're going to focus on. Again, our fingerprint region I've highlighted, and I'm going to largely ignore that. Although it's very distinct for the compound, it's very difficult with our reference numbers to pull out anything useful. So let's look for that COO bond first. The COO bond is really distinctive in infrared spectrums, and they appear in a really narrow window between 1680 1750. I put the little arrows there to show you that really narrow window they appear in. So if you see a peak like this, you kind of go, right, I know there's a COO bond. The other thing we're going to be looking for in ethanoic acid is the OH bond. Now for carboxylic acid groups, it's going to be absorbed around 2,500 and 3,000. We said earlier, if there's an OH group in alcohol, it's much higher. What makes it more distinctive in acids compared to alcohol, it is much broader. So if you go back and compare this shape to our previous one with the alcohol, it's much broader. Okay. So here we're looking at propanone, and we're looking at the display formula in the corner, and we can see that the most distinctive functional group is going to be that COO. And we've already mentioned it's got a very narrow window inside the infrared spectrum, so it's a really useful distinguishing read on the infrared spectrum, and we can see that there. The other distinctive thing that stands out on this spectrum is this one here. Now carbon hydrogen, the CH bond, is absorbed between 2,850 and 3,300. I've marked it out in the red arrows on the bottom, but if you see a peak present just under 3,000, it's probably due to the carbon hydrogen bond. So I thought I'd take a few exam paper questions. These are all from AQA. So we have a infrared spectrum here, and we're told that it's either an alcohol or an alkene, and you've got to pick one of those and explain your answer, and this is probably worth 1 mark in the exam. So what would you be looking for in the spectrum if you're trying to distinguish between an alcohol and an alkene? So if it's an alcohol, we're expecting there to be a broad OH peak, and if there's an alkene, we're expecting there to be a CCC peak present. So pause the video, have a look for those features. So how did you get on? You should have identified that it was an alkene, and you could have justified it in two different directions. You could identify that there was a CCC peak between 1620 and 1680, or you could say there was an absence of an OH bond being shown because there was no peak between 3230 and 3550. Now they expect you to get it right and then reference the correct wave numbers, okay? Now you get a data sheet, so use it. They're not expecting you to memorise these numbers, but they do expect you to quote the data. Interestingly, in this exam, under half the students got this one right. So students do find it challenging, but you guys are more capable of working this out. So the next question, we're shown a spectrum of an organic compound, and we've got to identify which compound produces the spectrum. So there's two ways you can approach this. You can look straight at the spectrum, identify key features on it, and then look for those features inside the compound, or you can identify key features on the compound and then rule them in out based on the spectrum. So take a moment, pause the video and have a go at this one. So there is a really distinct peak at around 1720, and that means we've got a COO bond present. So that means we can rule out ethanol and pent-2-ene. Okay, so now we're looking at distinguishing between butanone and propanoic acid. So something we could look out for is there an OH bond present on the spectrum? And so what we're looking to see is a very broad peak between 2500 and 3000. We don't have that. We don't have a broad peak there. We have a smallish peak just below 3000, so that would indicate CH, but that there is no OH present. So that means the only option is for this spectrum is butanone, option A. Right, last one. Which of these infrared spectrums could represent a carboxylic acid? Now the question has not told us which one, so we don't know how many carbons on that chain, but we're looking for a spectrum with a peak for the COO bond, and we're looking for a very broad peak for an OH bond. So take a moment, pause and have a look at these. So which of these spectrograms have got a peak around a COO bond? That's two of them have got a very distinct peak. We've got a little bit of one in C, but it doesn't have the same transmittance, that's why we're ruling out that one. Now we're looking for which one has a very broad peak for the OH bond, and that is only A. So in this one, A would be our carboxylic acid.